Greetings ladies and gentlemen, this is Freddy Matonzel and welcome back to my channel. Today I'm back with derivative of logs and exponential functions. So last time we discussed the derivative of trig functions. So today we'll be focusing on logs. So now I've written some formulas of what you need to know about logs. So let's say you are having a log of f at x and the what? And the base. So let's say this is the original what? Function. When you derive this, you'll have what? The derivative of your what? Of your function, which is you could call f prime x. So now, when you derive a log of a function base a, you can say the derivative of your what? Of your function all over your function multiplied by what? By ln a. So now, because of you are having a base, then you put your base where? With ln, and you forget about what? About log. When you are having ln and the function, you can derive this by saying, by applying this formula that says that the derivative of your function all over what? Your function, and remove what? Remove ln. These are what? These are basically what? Logs. Now, these are what? These are exponents. Exponential functions. So when I derive this, let's say I have e to the power function. Since my function is an exponent, it's impossible to what? To derive it. But then, with this formula, I can say that I can derive this by saying the derivative of my function multiplied by what? E and a function. Then, when I come here, this is a what? Is a constant. This is a constant. It could be what? 1. Sorry, not 1. It could be 2, 3, 4, etc., etc. So, if you are having a base to the power function, you can derive this by saying the derivative of your function multiplied by a base to the power function ln of a what? Ln of a base. So, when you know these formulas, it's easy for you to do what? To solve any problem that you come across. So, I've written some few examples here, and I would like to do them with you. So, let's say I'm given ln and a function of what? Of 3x plus what? Plus 1. So, I can say my f at x is equals to what? 3x plus 1. What is the derivative of my function? The derivative of my function is equals to, when I derive this, I will have what? I will have 3. Because 3x, when I'm having 1 here, 1 multiplied by 3 is what? Is 3. Then I subtract 1 from my index. I will have what? I will have 0. Then when I derive a constant, I get what? I get 0. So my derivative is what? It's 3. So writing this using my formula says, in order for me to derive ln in a function, I need to have a what? I need to have a derivative over what? Over a function. So now, what is my derivative? My derivative is what? Sorry. My derivative is 3 all over. What is my function? Is 3x plus 1. So, this is the derivative of what? Of this function. So, coming to log. Now, remember previously we did chain rule, product rule, and quotient rule. So in this case, if you could check, we are having a power. A power what? A power of 3. So now, how are we going to solve this? It's simple. First, you identify your what? Your function. So you can say your function is equals to x squared plus 1 to the power what? To the power 3. So now, what is the derivative of this? I can say the derivative of my function is equals to, I'm going to derive this using what? Chain rule. So 3 multiplied by 1, that is here, I will have what? I will have 3. Then I minus 1 from my what? From my 3. So I will have x squared plus 1 to the power what? To the power of 2. So remember, I said in order for you to derive a chain using a chain rule, you first derive the outer part, then the inner part. So in this case, I took this as my what? As my inner part. So that's why I derived first 3. Then now I'm going to derive my inner part. So my inner part was the derivative of x squared plus 1 is multiplied by 2x. Why? Because if I'm having 2, I'll multiply by 1, I'm having 2x, then I subtract 1 from my what? From my exponent, then I'll be left with what? With 2x. Then the derivative of a constant is what? Is 0. So now, that means here I'm having what? I'm having 6x, open bracket, x squared plus 1 squared. So now, to put this in my formula, remember, I said in order for you to derive a log, here we are having a what? We are having a base 10. I'm sure in high school they taught you the basics of what? Of logs. So now, here, my base is what? Is 10. So I'm going to apply this, that I need to have the derivative all over a function multiplied by ln of a what? Ln of a base. So what is my derivative? My derivative is 6. My derivative is 6x squared plus 1 squared all over. What is my function? I chose this as my what? As my function. So that means I will have x squared plus 1 to the power of what? Of 3. Then ln what? Ln of a base. What is my base? My base is 10. So when you do your math, I'll cancel this and this. So I'll be left with what? With 6x over, now I'll be left with what? With this, with x squared plus 1 ln of 10. So this is the derivative. This is the derivative of a what? Of this function. So it's easy to derive your logs, your ln and your what? And your log. You just apply the formula that says if you are having a log of a function and a base, then you need to have what? The derivative of your function all over your function and ln a. Or ln of a function, you'll say you need to have the derivative of a function all over what? Over a function. So now, coming to exponents of function or exponential functions. In order for you to derive exponential functions, you come here. You come to this. That if you are having e to the power of your function, then in order for you to derive this, you need to first derive your what? Your function, then you multiply it by what? By e and your what? And your function. And if you are having a constant to the power of a function, it's impossible to derive it. But then you can derive it using what? This formula. And say the derivative of my function multiplied by a constant to the power function ln of a what? Ln of my base or my constant. So now, let's use this. So this one, people, they may see it as if it's complicated, but it's simple. What is the derivative of cos? The derivative of cos is a negative what? A negative sign. A negative what? Sign. So now, how am I going to write this? I'm going to say, since this, let me say f at x is my what? Is my function. So it's cos x. So the derivative of my function is equals to a negative sine x. From the previous video, I showed you how to derive this. That if you derive your what cos, you get what? A negative sign. Then, now you apply the formula of an exponent. That if you're having e to the power function, then you can say the derivative of the function multiplied by what? By e to the power function. So that means I'll say the derivative of this is equals to, what is my derivative of a function? Is negative sine x. Then I multiply with e to the power function. My function is what? Is cos x. Then you get your what? Your answer. So now, coming to this example. On this example, if you could check, we're just having what? Constants to the power what? To the power functions, which is hard for us to differentiate. But using this rule, we can differentiate it. So how do we differentiate this? Let me write this here. I will say the derivative of a function. My function is what? First you need to choose what? Your function. So my function is 2x. Then the derivative of my function is 2x. So that means here I will say y prime is equals to the derivative of this. Now remember, to derive this is 7 is what? It's your a. 7 is what? It's your a. So now I can say the derivative of my function, in this case it will be what? It will be 2x multiplied by my what? My base. My base or a is what? Is 7 to the power of a function x squared multiplied by what? By ln of my base, which is what? Which is 7. Plus, what is the derivative of this? I can say f at x is equals to the square root of what? Of x. Then the derivative of this function is equals to, I can change this and say I'm having x to the power 1 over 2. So 1 over 2 multiplied by 1, I will have 1 over 2x. When I subtract 1 from my index, I will have a negative 1 over 2. So that means the derivative of my function is 1 over 2x square root. So this, I converted this back to what? To its root form. So now I can write my what? I can apply this formula. To apply this formula, I can say I'm having my f at x, which is 1 over the square root x multiplied by a. Your a is what? Your a is what in this case? Is 5 to the power what? To the power function. Ln what? Ln of your base, which is what? Which is 5. So you can simplify this further. You can simplify this further by saying y prime is equals to 2x multiplied by a to the power x squared ln of 7 plus what? This. So it will be 5. You can say it's 1 over 2 square root x multiplied by 5 square root of x ln 5. So this, it will be what? it will be your answer. So for more questions or for more information, contact the following numbers. But before that, I decided to give you a quiz today. So I beg you to do this exercise on your own and see or check your understanding. If you understood and you got your answer well, then don't forget to comment and subscribe, and please share this information to your friends, Facebook and all that. Bless you. I thank you.